Welcome everyone to the Berlin Functional Programming Group for this evening. I am genuinely pleased and delighted to have Gabriel Gonzalez as our guest speaker tonight. I have been an admirer of Gabriel's work for some time. In fact, I don't even have to research his bio. It probably won't be complete, but off the top of my head, I know him from the pipes library for Haskell. I remember long ago listening to the pipes versus conduit debate between him and Michael Snoyman. And of course, I know him from Beautiful Folds, from his wonderful blog, Haskell for All, which I think a lot of people find their way to at some point or other. And of course, now for the Dhall programming language, which he's going to speak about this evening. Before we get started, just a few small housekeeping matters. I'm putting some links into the chat. One, of course, as usual, if you'd like to buy a lovely Berlin Functioning Programming Group t-shirt, those are available on Teespring. You can follow us on Twitter. We have a YouTube channel. This talk will be recorded and put on YouTube. And we also have a channel on the FP Chat Slack group. If you have a question during the talk, please type your question into the chat, and I will find an opportune moment to interrupt. Actually, I think Gabriel has opportune moments built into his presentation, which is convenient for me. And otherwise, before we begin, maybe everybody could type into the chat where you're coming from tonight. Where are you right now? Maybe Gabriel's interested in seeing what kind of an international audience we have. Usually it's pretty global here.
Yeah, I recognize the names of some of the attendees.
Yeah, we have a few regulars and some previous and upcoming speakers as well. Oh, nice! Lots of Europeans, lots of Berliners. Oh, one other thing I wanted to say about Gabriel. I don't want to embarrass him with too much praise. I remember speaking to him at ZeriHack a few years ago, and he told me that he had studied something other than programming. I forget what it was. Biochemistry?
Biochemistry. Yeah.
Okay, good. I did remember. You taught yourself programming, or at least functional programming. You discovered Haskell on your own and became a major contributor to it. And I think that's really admirable. And you've gone on to be, from my point of view, a supporter of people learning Haskell, but also making Haskell and functional programming accessible. I think some of your more recent work has been in trying to persuade people that they need to do a better job selling it, and you've developed some techniques and shared ideas how to do that more effectively, which I really appreciate. So I think that's it for the introduction. I'm going to hand it over to Gabriel now. Let me just change the spotlight. And you should be able to share your screen.
I'll share my screen.
Away. And I will keep an eye on the chat and the waiting room and everything else for you.
Okay. First off, I want to begin by saying thank you for the very gracious introduction, and also thank you for organizing this meetup, so giving me the opportunity to speak and also to meet with all of you. So my name is Gabriel, and I work at Arista Networks. This is actually one of my open source projects, and today I'll be talking about Dhall, a programmable configuration language. Sorry, one second. There. So this talk is about introducing the Dhall configuration language to people who are functional programmers. So they've already drunk the functional programming Kool-Aid, and they just want to learn more about Dhall. I've organized this talk into 4 sections. In the first section, I'll talk about how to use Dhall as a plain old configuration file format without any programming language features. And the second part of the talk, I'll introduce the actual programming language features of Dhall. And then in the third part of the talk, I'll go more into the surrounding tooling around this configuration language. And then finally, I'll conclude by highlighting one of Dhall's strongest features, which is its language security guarantees. I've organized things so I'll pause for questions in between each one of these sections. But if you have a burning question, feel free to let Stephen know and he can bring it up. Or you can, I'll let you solicit the question. So the first question you might have, if you're not familiar with Dhall, is what is it? So you can, the way I like to, my 1-sentence summary is that Dhall is kind of like JSON plus functions plus types plus imports. And Dhall actually originated as an academic exercise to try to settle the following question, which is, would people tolerate programmable configuration files if they were not Turing complete? So to motivate this question, one thing that would come up very often in various social media or forums about programming is that some person would say something along the lines of, these configuration files I'm maintaining are getting too unwieldy. We should write them in a real programming language so we can take advantage of things like types or don't repeat yourself to make them more maintainable. And someone will inevitably counter by saying, I don't think configuration files should be Turing complete. So the thought experiment I posed was, what if a configuration file was programmable, but not Turing complete? Would people be fine with that? And it turns out that for some people, yes, that actually resolved the trade-off for them. And actually, I will go into more detail about like, I will actually, why people use the term Turing complete to address the issues. That'll come later on in the language security discussion. But that was the original motivation for the language. Even though it started as an academic exercise, people started using it and the project grew beyond my expectations. So I decided to just try to go with the flow and learned a lot along the way. So let me first talk about how Dhall is like JSON. So just like JSON, Dhall can model things like scalars, bools, texts, lists. It can model records and other things too, which we won't get into. And you can, and a host program can read a Dhall configuration file directly, just like you can read a JSON file. So here's an example Dhall configuration file. It looks kind of like JSON, except we use equals instead of colons and we don't quote the keys. And this is a configuration file you could read directly into a program, or if it's more convenient for you, you can convert this Dhall configuration file to a JSON file and then read the JSON file into your program. So for example, there's a Dhall to JSON executable, which you can use, which will produce this equivalent JSON right here. So sometimes the way I explain Dhall to people is just by showing them the correspondence between Dhall and JSON before I start introducing the programming language features. And so another thing you can do is, if you're trying to migrate an existing code base that uses JSON configuration files to start using Dhall, you can actually perform the conversion in the other direction too. So given a JSON file, you can convert it to the equivalent Dhall file. And there's a JSON to Dhall command for doing that as well. So for example, given this JSON up here, if we run JSON to Dhall on that, we get this Dhall file right here. And one difference between Dhall and JSON is that Dhall is more strict about types. So for example, if you have a list of records, then all the records in that list have to have the same type. And specifically, that means that the records in that list all need to have the same fields. So you can't have a field which is missing, but you can have a field which stores an optional value. So in the conversion to JSON, if there's a field like discontinued, which appears in some records but not other ones, then what the conversion will do is it'll use an optional value, kind of analogous to a nullable value in a programming language to represent that field. So for example, here we say discontinued is some false, so present value, which is set to false. And the other record, it says this value is absent, but if it had been present, it would have been a bool. And so JSON and YAML are a bit similar to one another. So Dhall also supports converting back and forth between Dhall and YAML as well. So given this Dhall configuration file right here, you can convert that to a YAML configuration that looks like this. And vice versa, given a YAML configuration like this one right here, if you run the through YAML to Dhall, it'll give you a Dhall file that looks like this one right here. And so far, these have been very small and contrived examples. So I would like to show you, before getting into the programming language features, is I would like to introduce what a real Dhall configuration file looks like. So what do large real world Dhall configurations look like that are using Dhall and Anger? And really, they'll actually look something a bit more like this right here. So Dhall has bindings to Kubernetes. And this is a Dhall configuration for a sample Kubernetes specification. So here it's importing a Kubernetes package, then using that package to define a nested data type representing a Kubernetes deployment. I won't go into detail about what all this means just yet. The only thing I will highlight is that Dhall provides support for defaultable records using this syntax right here with the 2 colons. And so that allows you to omit the large number of fields that can be that would have to otherwise be specified for a Kubernetes configuration, which can be quite large. And so if we take this Dhall configuration and we run this through Dhall YAML, it'll produce a valid Kubernetes configuration file, and it's guaranteed to be valid, right? So you know that it will never have, like, the myriad of YAML errors or type errors that plague large Kubernetes deployments. So it's correct by construction. And so what's cool though is that you don't need to know how to write that Dhall configuration file. If you have an existing Kubernetes configuration like this one, you can actually automatically turn it into the Dhall configuration we saw on the previous slide. So it's a long command, but here's what it would look like. And it's actually the composition of two shell commands. So the first one is YAML to Dhall. That's the command we already looked at. So the only difference is, in addition to specifying the file we want to convert, the YAML file, we also specify a Dhall type representing, and I don't expect you to understand this just yet, but this is basically a reference to a Dhall type which is hosted somewhere for what a Kubernetes deployment looks like. And so then Dhall will decode the YAML value into a value of this deployment type representation in Dhall. But if you were to do only that first command, you would get a giant Dhall value, because Kubernetes resources have lots of fields, many of which are just default values. But Dhall also provides a useful second command called Dhall rewrite with schemas, which if you give it as a record containing a bunch of defaultable types, then it will use those to simplify the configuration. And so the result is this file right here, which is essentially the same as the original configuration that we were looking at before. So this provides a smooth migration path for people who are using, say, Kubernetes, to start using Dhall and then start sprinkling on the programming language features to start eliminating repetition. And in addition to supporting JSON and YAML, Dhall supports XML, it supports Bash, because some things like Postgres use Bash as a configuration format with environment variables. It also supports Nix as well, although the Nix support is more of a proof of concept. I'm not sure if people are actually using it in production or in anger, but it's there if you want to try it out. But I mentioned before that you don't need to convert Dhall to another file format. You can read it directly into your program for certain programming languages. For example, the original programming language that Dhall was written for was Haskell. So if you have a Haskell program like this one, you can define it works. If you're familiar with Haskell, and specifically if you're familiar with ESON, the ESON package for handling JSON, it works in basically the same way, except instead of a from JSON class, there's a from Dhall class. So you just define this data types saying, what is the shape of the data that I expect, which is strongly typed. Then you derive from Dhall, and then you can marshal your your Dhall configuration file into a value of this type, and then do whatever you want with it in your program. And the languages for which this is officially supported are Clojure, Haskell, Go, Ruby, and Rust. We're always trying to work to expand the set of languages. There's also one I would like to mention, which while it has not officially announced itself as a language binding yet, is the Java binding as well. It's fairly comprehensive. As far as I know, it completely supports the latest language standard. So that's why I mention it. I say, based on user feedback, the most wished for language binding that we're currently missing is for Python. If you ever want to see what the latest list of supported language integrations or bindings, there's a website, docs.dhalling.org, which has a lot of documentation for the language, including a section on how to integrate Dhall within your project. So you might wonder, let's say I have a language that supports Dhall, but I also have a code base which is already using JSON or YAML. Which route should I use? Should I read Dhall directly, or should I go through the JSON or YAML intermediate? And what most people find works for them is that first they go through the JSON or YAML intermediate route. So because that lets them try before they buy. So they can, they have a JSON file, they keep a private Dhall configuration file, which they use for generating JSON. They check the JSON into version control, and they use that to make their personal life easier. After a while, as time goes on, this works out for them and they like Dhall, then they just tell their team, by the way, I've been using this Dhall file to generate this JSON. Can I just go ahead and check this into version control? Because that's the real source of truth here. So it's a more incremental migration path for introducing Dhall within your organization. It also works well because the tooling you need to do this is available on Windows and OS X and Linux as single statically linked executables. In particular, the executables for converting back and forth between JSON and YAML, but also the language server, and also a very useful utility for the Dhall utility, which we'll talk a little bit about later. And some of the benefits of, then the other route is like, once you really commit to Dhall, you may want to just go straight from the Dhall configuration file into your host program instead of going through the JSON or YAML intermediate. And there's some benefits to doing that too. Obviously, it's simpler, one less configuration file to keep track of. And additionally, it allows you to take advantage of some more advanced features. So for example, unlike JSON or YAML, Dhall provides support for what it calls unions or subtypes. And JSON and YAML don't natively support them. You have to encode them in a certain way with like a tag. So if you can just skip the JSON or YAML intermediate, it's a much smoother conversion process. A more niche feature, but it's still pretty cool, is that if you can read a Dhall configuration directly into your program, you can actually convert a Dhall function into a host function in this way. So here I have a small contrived example where I define a small inline Dhall function, which takes an input, a function input named x of type natural, and then it'll produce a list of 2 values. And I can take that Dhall code and I can embed it as a Haskell function using the same utility I use for marshaling a Dhall configuration file. And then I can call this function on 2, and lo and behold, it will print a list with 2 2s in it. And this has some limitations. It doesn't work on monomorphic functions, doesn't work on higher order functions, but when it does work, it's pretty nice. Okay, so I'm about to go into programming language features for Dhall, and here I thought I would pause to let people ask any questions they might have.
So we don't get a bunch of people unmuting at once. If you have a question, please go ahead and type it into chat. I don't see any right now, but they might come in.
I'll just wait just a second.
Yeah, we can give people 30 seconds to think of questions and formulate them.
Yeah. I mean, also you can ask, oh, go ahead.
I was gonna say, I really like how you have the migration path built in, or like the inception path built in.
Mm-hmm. Okay, so also feel free to queue up questions, even for previous sections. I can always go back and answer them. All right, I'll go ahead and proceed.
Oh, we have one. We have one.
Okay.
Andrew has a question. Andrew, do you want to go ahead and unmute and ask your question?
Yeah, hi. Just wanted to ask you, I was a bit surprised to see that in case of an optional value is given, you have to provide the type of the none case. And I was a bit surprised because basically I was asking myself, why do you need that if the sum type can give you the type itself?
So if I understand the question, it's for the empty case for an optional value, why do we need to provide the type? And the answer is because Dhall does not yet support bidirectional type inference. I have a slide later on where I'll go into more details about that. But the short answer why Dhall does not yet support that is because Dhall needs to have multiple language bindings. And so it limits the complexity of the implementation. So we have to, it takes time to roll out large language changes like that. So we have to, so that's one of the reasons why some type annotations are required in certain places.
Okay, I see. Thank you.
Yeah.
Okay, Hendrik has a question as well. Hendrik, would you like to unmute? No, okay. I guess I'll read the question. So the, I can read it. So the open brace, close brace syntax is more verbose and less readable than indent-based like YAML, Python, or Haskell. Is there any way or future roadmap to integrate the Dhall and indent-based notation?
No, not as far as I know. Nobody has, at least on the issue tracker and the discourse and various other ways that we get feature requests, nobody has requested that so far, and it has not been on my own personal roadmap. I would say, even if somebody were to ask me, like you just did, I would probably say no, although I'm not the only one who makes decisions. So Dhall actually is a governance system where every language implementation gets 1 vote on proposed changes to the language. So I only get 1 vote out of 5, I think, right now. But I would probably vote against that, mainly because most people who switch from YAML to Dhall explicitly cite the fact that YAML's indentation-based way of working with things is difficult to maintain for large configuration files, and they don't like its white space sensitivity. I think there's like a classic picture floating around of like somebody trying to, edit a YAML configuration file, and they had like this ruler attached pinned to their monitor so they can make sure they have the right level of indentation for what they're doing. So I would say that would probably not, at least for the use case Dhall is intended to address, that's probably something that would work against the design of what the language is trying to, at least our market would probably not like that feature.
Okay, I think that's it for questions for now. Thanks.
Okay. So Dhall is a programming language, which means that, among other things, you can factor out shared logic into immutable variables. So going back to our original configuration containing some user's home directory, the path to their private key, the path to their public key, I might want to guarantee that these three usernames all stay in sync with one another. And I can do that by declaring a variable called user, set it to Bill, and then I can interpolate that variable into these various strings. So we have variables, we have string interpolation. So that's an example of programming language features. In fact, actually, I can show this live in a demo on the website. So if you visit dhall-lang.org, this is a good entry point to the language. It provides links to lots of resources. And it also includes this running example I've been using up until now. So like here's the exact same code we were just looking at. And it's a live demo. So as you type, the right pane will update. So if I replace my name right here, you can see that it's updating in sync on the right. So you can visually see the fact that everything is staying in sync with one another. And conceptually, when you're converting a Dhall file with programming features into JSON, it happens in 2 steps. So the first step is actually that we convert the Dhall file to a inert canonical normal form. So where you just evaluate all the programming language features, which will leave us with pure data. So that's what this is right here. And the second step is we'll take that pure data and we'll convert it to JSON. So like this, for example, or YAML. Also, you can do this from the command line too. So there is a Dhall command, which if you give it a Dhall program on standard input, it will interpret that program and then provide the result on standard output as well. So Dhall's data model provides the following simple types. So we got Boolean values, we have text, we have natural numbers, which are unsigned integers. And then we also have a separate type for integers. So these are always signed. Syntactically, you always have to provide the sign for an integer. So plus if it's positive, for example. And natural and integer are a separate type. So you need to explicitly convert between them within the language. So this is something that may surprise people who are used to other programming languages that don't have a separate type for natural numbers. And part of the reason why is because many useful utilities, like the correct domain for those functions, is actually a natural number, or the correct result for a function might be a natural number. For example, the length of a list should only return a natural number, not an integer. Or if you drop an element from a list, the number of elements to drop should be a natural number, not an integer. So that's why Dhall provides special support for this natural type. And most utilities within the standard library work in terms of natural numbers. Dhall also provides, one other thing. Natural numbers and integers are unlimited precision, but Dhall provides double or floating point numbers, which are essentially IEEE double floats. So these are not unlimited precision numbers. And Dhall also provides support for complex or composite types. So we have optional values, which are analogous to nullable values in many languages, like in JSON, if you're converting a JSON, like none natural will convert to a null in a JSON configuration, whereas sum1 will just get rid of the sum and convert that to just 1 in JSON. You also have lists. So here's an example of a non-empty list. And I mentioned before that some things require explicit type annotations. An empty list requires an explicit type annotation. So that can surprise people who are new to the language. Dhall also provides language support for records. So it's kind of like JSON, except you replace colons with equals and you don't need to quote the fields most of the time. There is actually a way to quote the fields if you want to use some weird characters, but you don't have to. And finally, Dhall has unions, which are basically like sum types. And usually the idiom for using them is that you declare the type ahead of time, So like there's an example type, which is a tagged union, where there's a left tag, which can wrap a natural number, or a right tag, which can wrap a Boolean. And then you can use it by saying, okay, I want the left tag to wrap a 0. And also these unions can have empty tags, and that would just be an enum. So you can have a DNA base pair, which can be A or T or G or C. And then this is an example of how you would just list one nucleotide in a list. So complex types within Dhall can be nested arbitrarily. You can have 3 sums nested, so you can have multiple levels of nullability if you wanted to do that. So this is similar to JSON or YAML, with the exception of nullability, which JSON and YAML cannot nest. It's basically like JSON or YAML. And unlike INI or TOML, which have some limitations about how you can nest things. I want to explicitly highlight some of Dhall's text language features. So among programmable configuration languages, Dhall's text support is best in class because it provides support for multi-line string literals and also string interpolation. In particular, Dhall support for multi-line string literals is stolen straight from Nix, which has almost the exact same feature. And it uses the exact same syntax too. So it uses these 2 single quotes around the string literal, and they're supposed to convey big double quotes. That's the mnemonic for remembering how to use them. And just like Nix, Dhall will automatically strip leading indentation from a string literal for convenience. Dhall also supports, just like Nix, a dotted field syntax. So if you have a nested record like this one right here, you can condense it by instead of writing something like a.b.c equals 1, a.b.d equals true. And this comes in handy for deeply nested data types, such as in Kubernetes configurations. Dhall is a slightly more flexible than Nix in this regard. So this example works for Dhall, but the analogous record in Nix will actually cause the interpreter to reject it. So Dhall has a slightly more principled way of handling this notation. And Dhall also has functions. This is like probably the most important part of any programming language. It allows you to reduce repetition by defining factoring shared logic into a utility function. For example, let's say that I want to create a list of configurations in JSON, and I don't want to just copy and paste each record and then edit it and hope that I don't make a mistake. So instead, what I can do in Dhall is I can define a make user function. And this right here is Dhall's syntax for defining an anonymous function. Well, it's anonymous up until we give the function a name like make user, but this would be like a lambda in Haskell. So this function takes a single input called named user of type text. And then this right here would be the body of the function. And within the body of the function, we define 3 variables, home, private key, and public key, which each build upon the previous one. And then this is a convenient syntax Dhall has for packing variables into a record. I think other languages, like I know Haskell has a feature just like this, and maybe other languages do too. And then we can, once we define this make user function, it's very easy to add new users in a less error-prone way. We can just say make user Bill, make user Jane. In fact, we can actually show this on the website. So we go, the Dhall configuration language has an example just like this one. And we can see, as I add a new user, and now I just added yet another user to the list. And this is significantly easier and less error prone. So this is where people are coming from when they say, I want my configuration files to have programming language features to make them easier to maintain. Dhall is also typed, so you can validate configuration files ahead of time using its type system. So here I've added some additional non-required type annotations throughout this just to make things more clear. So for example, one new thing is I actually can define a type. So I can say let config, which is a type, be set equal to this. So in Dhall, there is no distinction between declaring types and declaring values. They use the same let notation for both because types are first class in Dhall. And so once I've defined this type using let, I can actually use that type within downstream type annotations. So for example, the make user function has type, and it's a function from a text value to a config, where config is the type we just defined up here. And then we can also give types to these intermediate let bindings right here. We can also give a type to the result. So configs is going to be, or result is going to be a list of configs. You can put type annotations basically anywhere within the code. They don't have to only be on let bindings. It's just a structured way of organizing things. And so this is another feature which Dhall has stolen from Nix, which is the ability to import things by file path. So it's actually, in Nix, you have to use an import keyword. In Dhall, there is no keyword. You just put the path, and that's how you import it. So for example, if I save the number 2 to a file called number.dhall, then within another Dhall expression, I can write, I want you to add number.dhall and number.dhall. And that's basically the same thing as adding 2 plus 2. And if you want to organize the code a bit more, it's more common for each file to just give it a succinct name, so you don't have to keep adding the extension everywhere you use it. So this would be a more production-ready idiom. But you also, not only can you import files by their paths, you can also import environment variables. So you can say, hello, my name is, and then get the environment variable for the user and render it as text. So we can interpolate it into the string. And another thing is you can actually go much further. So this is something that Nix does not support. Well, not in the same way, but so in Dhall, you can import things by URL. So let's say I want to use, and I can import any expression by URL, not just data. I can import functions, so code from URLs. So here's an example of doing just that. So here I have a utility function, which is hosted online within Dhall standard library, which is called the Prelude. And it's a generate function. And if I were to open that in my browser, it would look a bit like this right here. And we don't need to read the code in that much detail. Just know that this is essentially raw text, UTF-8 encoded, hosted somewhere on the internet. And then if it's valid Dhall source code, we can import it. And so if we import in this generation function, what it does is it's used for generating a list of values using a generation function, where the input to the function is the index into the list. So we'll show an example of that. So here we say, okay, this is the same make user function that we defined before. And then we're going to wrap it with another function called build user. So given an index into our list, it'll call make user with a user named build, and the suffix of the username will be whatever the list index would be. And then to create the list, I'll say generate 10 configs using the build user function. And the website has exactly this example, so let's try it out live really quickly. So here's what the equivalent YAML would look like. And if I just type add a 0 here, now we have 100 user configurations instead of 10. So again, makes things much easier to maintain if you want to roll out a large scale configuration. Dhall also has language support for tests. So within Dhall standard library, there's a utility called less than equal. Mainly because there's not actually an operator for this purposes. Dhall is very parsimonious with the operators that the language provides. There are no user-defined operators, only built-in ones. But there is a named function for comparing two natural numbers to see if one is less than or equal to the other one. And so this function, I won't go into how it's implemented, but there are tests for how it's supposed to work. So for example, we say that 5 should be less than or equal to 6. 5 should less than be equal to 5, but 5 should not be less than or equal to 4. And these tests are verified at type checking time. So you can do a static analysis of code using these tests. And so one of the things I like about the way Dhall is designed is that in Dhall, many higher level features are just the composition of smaller orthogonal features. So for example, in Dhall, a package is just a record that you import, and the record might be nested, like to organize things. So we saw an example of that with the Prelude. So if you go to the Prelude, if we were to open it up right now, in fact, I will actually go to the website rather than the raw Dhall code just for a second. So you can see. So the Prelude is a GitHub repository. It's also available using that convenient domain. And the top level package basically is a record which contains which imports a bunch of sub records, and each of those sub records looks something like this. So this record in turn imports a bunch of utilities, which are functions. And then if we go to one of those functions like and.dhall, we'll see the code for that function. So if we just combine support with imports and records, then we have a package system. And records can store not just values, but types as well. Because remember, types are first class in Dhall. So I can say, okay, import the Prelude, assign it to a value called Prelude, and I can access functionality like a record field. So I say Prelude, so Prelude has a bool field, which is a record, and that bool field has a not field. So I can say prelude.bool.not is true, and then call that on true. You can also import sub packages directly. You can also import just the not function directly. So the level of granularity is up to you, how you want to write your code. And we can just verify really quickly, like if we can just test this using the same interpreter right here. So I'll just replace this code with that, and then it should give us not true. I wonder why it's pausing here. Well, I'll skip that, but I'll have to figure out later why that's taking a little bit so long there. Okay, oops. So another emergent property of Dhall is templates. So in Dhall, a template is just a function that interpolates text. So here we've created an anonymous function, which given an input named args, which is a record, and the record will have two fields, a year, which is a natural number, and a copyright holder, which is text. And then we'll template a string using the input to that function. And because it's just a function, the way you instantiate a template is function application. So for example, from the command line, I can say, okay, so I've saved my template to template.dhall. So I can use that file as if it were a function within Dhall code. So I can say, okay, apply this template.dhall function to this data, which is, the year should be 2020, the copyright holder should be Gabriel Gonzalez. And then the Dhall text command will essentially interpret the code and then render the result as raw text, assuming the result is a text literal. Another emergent property is support for schemas. So by schema, I mean like a file that a configuration is validated against, representing like what's the shape of the data should be. And so in Dhall, a schema is just a type annotation that you import. So I could save this Dhall type to a file named schema.dhall, and then within the real configuration, config.dhall, I can just add a type annotation to my record saying, I expect this record to have the type contained within this file, and the interpreter will validate the file against that type at type checking time. Another emergent property is property tests. So it turns out that the interpreter can actually abstractly reason about code that has variables which are not known yet. So let's go back to our less than equal function. It actually has two other tests, which are property tests. You can read this test as saying, for all natural numbers n, I want to assert that 0 is less than or equal to n. And also I want to assert that n is less than or equal to n. So unlike, say like a Haskell property test, where the property test is checked using random input, the interpreter is actually verifying that this is true for all possible values of n. So it's correct. It's I guess sound or complete or whatever the right name for it is. And it works because the interpreter can normalize abstract expressions. And we'll show a more worked example of that later on. Actually, like the property test might be the wrong name for this, but I don't know what the correct name for this would be. Okay, so the language also provides a restricted set of primitive operations. There's a website. So the website documents the full list of keywords, operators, named functions that, and they're organized by the types that they tend to be associated with. So check that out, which will show you like what are the building blocks that you can use. And I'll provide the high level summary, which is that there are a few things that will surprise new users. So first off, there's no support for text introspection whatsoever within the language. So for example, you cannot ask Dhall, how long is this string? You also cannot break a string into substrings. You can't compare two strings for equality. Another thing is that there's no support for double arithmetic. So there's support for natural arithmetic, and a little bit less ergonomically, there's support for integer arithmetic too, but definitely not double arithmetic. That may change at some point, but that's the current state of affairs. And the last thing that's really surprising to people is that the language has support for an equals operator and a not equals operator, but they only work on Boolean values. So you can't compare text for equality. You can't easily compare natural numbers for equality, at least not using this operator. And so there's a page which explains why these design choices were made, but for most cases, the reason is that the language is designed to discourage people from using weakly typed programming idioms, right? So like, for example, instead of using a string, you should be using a sum type or an enum specifically to represent the set of all possible values. Dhall is also a total functional programming language. So this means that a Dhall configuration file will never hang, crash, or throw exceptions. It might fail the type check. That's pretty much the only failure you're going to get. Well, there's some other failures like cyclic imports, for example, but basically, at least it's never going to crash on you or do something that's bad. So one benefit of being total is that Dhall supports what's called strong normalization. So this means that not only can we interpret expressions that return plain data, we can actually interpret functions abstractly, meaning that I can interpret a function even though I haven't been given all of the function's inputs yet. So here's an example within the REPL. So I'm going to import the generate function that I used before, and the interpreter will helpfully display the type. And I will walk you through this type. So it says generate is a function that takes 3 function inputs, 3 function arguments. The first function input named n, which is how many elements of the list to generate. That's a natural number. The second function input named a is a type. So this is going to be the type of each element in the list. And the third input named f is the generation function. So how to generate each element of the list. It takes as its input a natural number representing the index into the list, and then it will return a value of type a. And then given those 3 inputs, it will return a list of a's. So now I can actually tell the interpreter, I want you to interpret the generate function, but I've only given you one of its 3 inputs, the number 10. So you know that you want to generate a list of 10 values, but I haven't told you anything else just yet. And the interpreter is totally happy to interpret that. And it'll say, okay, the result is now a function that has 2 remaining arguments. So again, still a and f. But I know that it's going to generate a list of 10 elements. And I know that the way it's going to do that is by calling f on the numbers 0 through 9 to generate those elements. So this provides an easier way to comprehend what a function is doing on sample input to reason about it more easily. Dhall does not natively support recursion within the language. So like, for example, a let binding cannot refer to itself, and it provides all sorts of other checks to make sure that there's no way you can introduce general recursion. Recursion is not, so structured recursion, as opposed to general recursion, it's not impossible, but it's not going to be ergonomic either. For example, this would be the Dhall type for modeling JSON. So JSON is a recursive data structure conceptually. I don't expect you to understand that data structure, but there's a document on the web page which explains, like, for people who are authoring Dhall packages, if you really need a recursive data structure, here's how you can model it within the language. Maybe at some point the language will have better native support for recursion, but at the moment you have to encode it in some way. Dhall's type for inference is also very limited. So as I mentioned before while answering your question, Dhall does not yet support bidirectional type inference. So that means that types or type annotations are required in a few places. For example, an empty list requires a type annotation. An empty optional requires the type of the value that would have been there if it were present. A function's input requires an explicit type annotation. That's not so bad because that's the case for a lot of mainstream languages anyway, so most people are fine with that one. This one bugs a lot of people. So using a polymorphic function like map requires explicit specialization types. You have to actually apply it to the input and the output type of the map here. And there's overlaps. Like this type right here is always going to be the same as this type right here, but you have to say it twice. So we're working on slowly fixing issues like these, but the main reason we haven't yet is because we have to make sure it's supported by each language implementation. So it's the Haskell implementation is not like the source of truth for how Dhall works. It's just one implementation among many.
Gabe, can I interrupt for a second?
Yeah, go ahead.
Oh,
well, this is a question
timing.
point slide. Yeah.
I was about to say, are you going to do questions because they're piling up? One quick question for me. Not really a question. I know that some people have never heard of total programming languages before. So maybe if you could briefly explain what that is, what you mean by that, and why you would want a language to be total, since it's going to sound like it's missing something.
Yeah, I would say like total functional programming. I mean, I won't speak for the people who started the field, but like from my point of view, the purpose of total functional programming is to get us closer to the goal of writing programs that can never fail in some way. So like as a starting point, you'd like to like verify that a program will never throw exceptions, or a program will never have unexpected data or unverified inputs or crash on some unexpected input. And total functional programming is trying to, make that a reality, like make it actually realistic for programmers to do. So Dhall does not represent the vanguard of total functional programming. Dhall is actually very simple total functional programming language. Like there's much more advanced research. Like for example, like, Dhall can never hang, that is true, but it can take a very long time. So like, later on I'll show an example of interpreting the Ackermann function in Dhall, and that will take longer than the age of the universe to ever complete. But there's more sophisticated research in total functional programming to do things like, what if we could apply time bounds or complexity bounds to functions instead, which would provide even stronger guarantees about how well behaved this code can be. So I say in general, total functional programming is just trying to build programs that can never break under reasonable constraints or requirements.
And to do that, you have to kind of make it weaker. Well, I don't know if weaker is the right way to put it. You have to take some things away on purpose. Like you can't compute anything in Dhall, right? It's not Turing complete.
Yeah. So like in general, I think there's some general principle that says that like, for any type system that is sound or complete, I think somebody who's an expert can correct me if I'm wrong, but I think like there'll always be some valid programs that the type system will reject. So yes, so you will, for any total programming language, especially if you're coming from a language that's not total, you'll have to get used to changing the way you program a little bit to fit within the straitjacket that the total programming language requires. So for example, like Dhall forbids recursion. That's actually not required to create a total programming language. So there actually are total programming languages that support recursion natively within the language, like Agda, for example. But that's just an example how like sometimes a total programming language can force you to change the way you program to accommodate whatever straitjacket that language happens to impose upon you. So just so that it's easier to convince the type checker that your program is good and well behaved.
Okay, thank you. Thales has a question, and I'm going to ask it for him, or Thales, I'm not sure how to pronounce it. How did you make the web version of Dhall in dalllang.org? Did you use something like GHC.js, or does it send the input to a server?
It uses GHC.js. So the package for doing that is not published to Hackage, but if you find the GitHub repository for the Dhall Haskell implementation, you'll find the code that powers that website. So yeah, it is actually, your browser is actually running that code and it's not going to a server.
Okay, and Ulrich has a few questions. Ulrich, do you want to unmute?
Yep. So actually, just two very simple questions, I think. One is text handling. So what's the encoding by default you're using? And something I came across a couple of times in configurations is if you want to limit your alphabet that you allow on your input, say whatever, only certain types of characters and so on. Is that somehow possible? And the second one is you said that there's doubles. I was wondering, what about fixed point values?
So to answer the first question, Dhall text literal. So I mean, Dhall text literals are opaque. So the language standard does not specify how they are internally represented. So they could be internally encoded as UTF-8 or UTF-16. I assume most implementations use UTF-8 internally under the hood. You would never be able to tell within Dhall because there are no utilities to, like Dhall does not support bytes. So you cannot convert the text to bytes yet, although we're considering adding support for bytes. There are, so also to answer the second part of that, which was, can you assert that text matches a certain character set, like ASCII or maybe some other restricted subset of characters? Currently, no, again, because Dhall does not yet support text introspection. So like there's nothing like, there's no regex support in Dhall or anything remotely similar. And so the second part of your question was, how do we, sorry, actually, I forgot the second part. Can you repeat it?
Yeah, that was just for fixed point support.
Oh, yeah. No, the language does not provide native support for fixed point numbers. You probably have to model them as like, a ratio or something like that.
Okay, thank you, Ulrich. Ich habe dich vermisst. Harold has a question. Harold, nice to see you, Harold, by the way. Would you like to unmute? If Harold is still there. Oh, there he is.
Takes a while to get there. How y'all doing?
Doing great.
Hey there.
I'm just curious, is there any security implications about loading code from the internet?
Oh, yes. I have an entire section of the talk devoted to that. So I will defer the answer to that section if that's okay with you. So I go into this in quite a lot of depth.
Okay, thank you.
Yeah.
Okay, that was an easy one.
Yeah.
Okay, Shang has a question. I need to ask it. What would be the usual scenarios where one would test Dhall code? Would you say that there's some peculiarity regarding Dhall tests given that it's a configuration language?
There are two common ways that people write tests in Dhall. One I've talked about so far, which is that if you're authoring a utility, you may want to write unit tests or property tests for that utility. The second use case is, which I'll show on a later slide, is you can also use tests for validating your configuration. And I'll show you exactly what the idiom for that will look like. And so I'll expand upon it in more detail when we get to that slide.
Okay, and Mateus has a few questions that I think I need to ask as well. Does Dhall support lazy infinite lists?
No. So like for people who are not familiar with type theory or programming language theory or slightly related category theory, there are sort of two ways to do recursion. There's recursion and there's co-recursion. Both of them can be modeled in Dhall, so like using what are called F algebras or F coalgebras. But Dhall does not provide language support for doing that. So like the simple answer to your question would be the way you would model a lazy infinite list in Dhall would be a record with two fields. One would be the starting state, and then the second field would be a generation function to generate the next element in the list and then produce a new state. So that would basically be the co-recursive encoding of an infinite list.
I need to get someone on here to talk about F algebras now that you mention it.
Mm-hmm.
Interesting subject. Mateus has another question. If equals and not equals, the operators only work with bools, how could one compare two constructors of a sum type?
There is a very verbose way to do this. We're actually, so the short answer to that is there is a way to do this. It's inefficient and it's complicated. If we were to add language support for this, the most likely way we would do this is by adding support for wildcard pattern matching on sum types. Because that most of the time when people want to compare two enums or sum types for equality, well, first off, it would make it easier to implement that equality because you could just do it in that way. But most of the time, they just want to check like, does this match one constructor of that type or not? And that's what a wildcard pattern match would help with.
Okay, I missed his follow-up question from the previous one about, well, when you were talking about the co-recursive implementation of infinite lists. Would it be lazy? Is his follow-up question.
I mean, it would no. So I mean, well, so let me clarify. Dhall, the language standard does not specify, because it's total, there's no semantic distinction between whether or not evaluation is done strictly or lazily, other than like how much time it takes to run. Like you'll, in particular, like lazy versus strict would not change whether or not a Dhall program hangs because it never hangs. There's like no concept of bottom in Dhall, and there's no errors either that would accidentally be triggered either. So the Dhall program, like the answer would be, the pedantic answer would be you cannot tell if a Dhall program is lazy or strict. But I guess the moral answer to that question is that encoding of a initial state and a generation function lets you request as many elements as you want based on how many times you run the generation function. So if you only call it 10 times, you're only going to get 10 elements. And there would be no way within the language to request all the elements of such a list, because there is no way in Dhall to say like, I want you to run this generation function an infinite number of times. That's just not expressible within the language.
Okay, any other follow-up questions, Mateus? Looks like, okay, no, good. Thank you very much. A few more questions, if that's okay, Gabe.
Yep.
Eduardo has a question. Eduardo, would you like to unmute? Everybody wants me to read them. I do my best here. What is the relation between Dhall and simply typed lambda calculus? It feels oddly similar.
Yes. So when Dhall first started out, it was based off of System F, then which is one type of lambda calculus. Then it became based more on calculus of constructions, and then it became based off of another slightly related. So there's a. So sorry, I'm opening up the language standard because it actually has a statement at the beginning of the standard widget where it says exactly what it's based off of. Or I thought it did. Here we go. It's closest to a type system known as CC omega, which is kind of similar to the calculus of constructions, except a little bit different. I won't go into the difference, but that's the closest thing in the literature that to what Dhall is doing.
Okay, any follow-up questions, Eduardo? Okay, I guess not. One more, I think, for right now. Friend of the meetup, Torsten. Torsten, can you unmute to ask your question?
I can. Can you hear me?
Yes, go ahead.
Hi. Nice talk so far. Enjoyed a lot. Quick question, probably easy to answer. So what happens if you import code from the internet, but you don't have it? Is there any caching going on?
Yeah, so basically the import will, the interpreter will just not, it will basically say like, I couldn't retrieve this code, right? Okay. So that's the closest thing. Like there are no, so Dhall has 3 phases to interpretation. So there's import resolution, then there's type checking, and then there's evaluation. So when I say a Dhall program can never throw exceptions, the precise statement is a Dhall program, once it reaches the evaluation or normalization phase, then it can never fail. So like it can fail during the type checking phase with a type error, or it can fail during the import resolution stage with an import resolution error, like I couldn't retrieve this HTTP request. So it can't fail in that sense. But like once you get to normalization or evaluation, then you're home free and the program is basically is guaranteed to succeed. So one of the benefits of that phase distinction is that you can verify a configuration file ahead of time, be like, okay, I verify that import resolution and type checking succeed at the moment. And now I can make sure that it'll succeed at normalization time. In fact, you can actually pre-resolve a file to like, inline all of the imports as well. You can also cache imports, which I'll get into a little bit later, so that you only need to fetch them once, so that even if they're not available later, the program will still succeed. So there are lots of ways to work around missing imports within the language.
Cool, thank you.
Yep. And also, I want to mention a lot of the ways that Dhall works around it are, again, stolen from Nix. Dhall draws very heavy inspiration from the Nix language to solve a lot of these design decisions.
One more question from Thales.
Yeah, go ahead.
Follow up to Eduardo's question. Do you have some recommendations of bibliography or courses that cover such topics? He's talking about the, was it the continuation calculus specifically?
So this is about like the various type systems. So for me, the first starting resource I recommend for people is a dependently typed, a tutorial implementation of a dependently typed lambda calculus. It's like a paper which is also tutorial. And the reason I like it is because it's kind of like a Rosetta Stone. It shows, here, let me just pull it up really quickly. Tutorial implementation of a dependently typed, something like that. Yeah, here we go. And the reason I like this paper a lot is for people who are novices in programming language theory, it actually shows the notation, the logic notation and Haskell code side by side. So it's like a Rosetta Stone. So you can see like, okay, now I understand like how this logical notation corresponds to like code, like actual executable code. So it's a very good introduction to programming language theory in general. Another useful introduction is written by Simon Payne Jones. It's called the Henk programming language. Henk, a typed intermediate language. So this paper was actually the direct inspiration to so it's actually the Dhall has a direct lineage from this paper. So like Henk inspired Morte, which was the predecessor to Dhall, and then Morte led to Dhall. So this also will help you better understand how Dhall's type system, at least its initial type system, worked. And then the third thing I would recommend is just search for resources on pure type systems. Pure type systems are sort of like a structured way of talking about different type systems like System F, calculus of constructions, and so on. And once you learn that general framework, it makes it much easier for you to pick up and understand new type systems that people throw around all the time. So that's how I'd recommend like getting into learning about these sorts of lambda calculi, and then their associated type systems.
Does Simon Peyton-Jones know about Dhall?
I don't know. I never asked him or talked to him about it.
Okay, no more questions for now.
Okay. So now I'm going to go into the tooling behind Dhall. So I hinted at earlier, there's a REPL, and so you can define values and including you can have a value which is equal to an import. So here we're going to import the prelude. The REPL has support for tab completion, so you can complete keywords, identifiers in scope, built-ins, and also fields of a record. So it makes it very easy to explore what values a package provides, like the prelude, for example. Another thing that Dhall provides is, so these are all subcommands of Dhall. So there's a Dhall REPL subcommand, and then another useful subcommand is the Dhall diff command. So given two Dhall expressions, it will compute a semantic diff of that. So it actually goes one step further. It's not just a syntactic diff of the expression, it's semantic, meaning it will actually do some interpretation before comparing the two expressions. So for example, let's say we compare, in this case, all it is, because these two expressions are already in normal form, it happens to be a syntactic diff. So we're saying, okay, so what's the difference between this record and this record right here? And then the diff will say, okay, well, the record on the left has a field named Y, which is not present in the record on the right. Vice versa, the record on the right has a field named Z, which is not present in the record on the left. And both records share a field named X, but they differ in that the left record begins with a 1, and the right record ends with that list ends with the 4. This is what I mean when I say it's a semantic diff comparing the two expressions. So this is a useful way. It'll always omit anything that's completely shared. So like if these two records had like 52 other fields that were all the exact same, then it would just elide them with a ... saying everything else matched. And this feature, and it's not just a subcommand you can use on the command line. It's also used in two other places within the interpreter. So for example, anytime you have a type error where there's a type mismatch, it will display a semantic diff between the expected and the actual type. So here I created a contrived example where I created a person type, and then I created a record which has a typo in this field label right here, and I gave it the person as a type annotation. And so that will trigger a type check where we'll compare the expected type with the actual type. And it says, oh, aha, you made a mistake. Right? I was expecting a field named age, but I found a field with one extra E in it. And then that makes it very easy to correct typos in very large configurations, which are very common when dealing with unwieldy configurations. Another way in which Dhall uses these semantic diffs is in tests. So if there's a mismatch between a test's expected output and then the actual output, Dhall will display the difference using the same semantic diff functionality. And these semantic diffs also support diffing text. So it will actually highlight the text in green or red. I can't show that here on the slide because the pandoc, or at least the generated pandoc, doesn't support red or green highlights easily. But the idea is that here I have some code for rendering a Dhall representation of a JSON object, and I'm asserting I want it to be equal to the string when it's rendered. And then the real string that it evaluates to actually will have a space here and here that need to be present. And if you were actually to run this from the command line, it would highlight those two spaces in red to indicate that they were missing from the actual test result. And another Dhall subcommand that's really useful is the Dhall hash command. So given an expression, it will compute a semantic hash of that expression. So to be precise, what happens is that first, it will interpret the expression and reduce it. It will beta normalize the expression, and it will also alpha normalize the expression. Then it will actually, there's a standard way of encoding every expression in binary. So that's a part of the language standard. And then, so it'll encode that expression as bytes, and then it will compute a SHA-256 hash of those bytes. And because of that, what it means is that two expressions that are alpha beta equivalent will have the same hash. Here's an example. So in this first case, I am hashing a function which takes one input named x of type bool and returns a list. And the first element of the list is x and true. Second element of the list is x and false, x or false. And so that has a hash beginning with 486b56. And now I'm going to hash this other function saying, given an input named y of type bool, return a list with just two y's in it. And that has the exact same hash. And the reason why is because the Dhall interpreter has support for reasoning about simple Boolean arithmetic. So it knows, for example, that no matter what x is, x and true is going to be the same thing as x. So it knows that these two expressions will evaluate to the same canonical normal form. And also, when it will alpha normalize the expressions, meaning it will actually rename all the variables to underscore and take care of, like, shadowing or shifting things so that there's so that there are no collisions. And when it does so, then it realizes that actually, even though the fact that this is named X and this is named Y, these are still the same expression, because if you alpha normalize them to use underscores everywhere, then they're the exact same expression. So that's how it knows that these two expressions produce the exact same hash. And so this can be very useful when refactoring code and verifying that your refactor is behavior preserving. Because if the hash doesn't change before and after the refactor, then you know that you didn't semantically change the code in any way. And in particular, these hashes are insensitive to comments, they're insensitive to coding style, they're insensitive to variable names, and they're also insensitive to how you lay out your modules. So if you have like one big file or you split into several smaller files that import each other, as long as the final result is the same, the hash will be the same, which is very handy. Again, this feature is stolen straight from Nix. In Nix, you can hash, well, you can hash derivations, not Nix expressions, but it's morally similar. So hashing is used in two other places within Dhall. So you can hash expressions that you import. So people are asking, like, what if the URL is like, is it safe to import a URL? Well, it is if you hash it, because the hash actually pins the contents of the import. So there's a one-to-one correspondence between an expression and its hash, modulo hash collisions, which are hard to get. At least hopefully they are hard for the near future. And so this means, for example, that the interpreter, when it resolves this, it will actually check that the imported expression matches the declared hash. So if someone tries to tamper with the imported expression anyway, then it'll be, the interpreter will reject the import. And it'll warn you and say, like, what was the hash it found and what was the difference between them. Also, the other purpose of this hash is that if you protect an import using a hash like this, then the import will be cached locally the first time you import it, and then it will never be resolved ever again, as long as your local hash has that import. Because the Dhall interpreter maintains a cache by default in your local home directory of every import is ever imported that's protected by a hash. And this content addressable store uses the hash as a lookup key. And because it's content addressable, it can be immutable, it can be append only, so you never need to invalidate the cache ever, unless you're just running out of disk space for whatever reason. So that makes these imports safe and immutable once you've attached a hash to them. So Dhall also provides some limited IDE support, so it's not going to be as sophisticated as a production IDE, like, I don't know, like the things that JetBrains or IntelliJ will release. But like, it provides some basic features like type on hover or auto completion, and then some other features which may be a little bit more specific. So here's in this example right here, it's showing how Dhall can complete file paths. So it'll actually see what's on the file system and use that for completions whenever you're importing something. It can complete identifiers or fields of records or keywords or anything else that is in scope. It does type on hover. So you'll see in just a second where we'll hover over some values and see, okay, true is a bool, zap is a text, and an alignment can be chaotic or lawful or neutral or whatever that said. And for people who are not familiar with the language server protocol, anything that implements this protocol will be supported amongst basically all editors. So the language server will work with VS Code and Sublime and Emacs and Vim and pretty much any other editor. Dhall also has support for a documentation generator called Dhall Docs. So this, if you use Haskell, it plays a role analogous to Haskell's Haddock tool. And I have some links to some example generated documentation. So for example, here's the generated documentation for the prelude. So it'll show like what are some top level files that are available. You can also jump down to, let's say, the bool file, the bool subpackage, and then that will have several utilities. Their types will be next to them like this. And we can click on one of these utilities. If something has tests, it'll actually highlight those tests in the beginning of the documentation. So like, because tests themselves are a form of documentation. If there's a doc string, then it will include that in the generated documentation. It also has support for jump to definition. And this won't actually do it justice, so I'm actually going to switch to another example function. So there's a large utility intermediate function called render as, which powers a lot of the JSON support. This is a large function, as you can see. So if I click on, let's say, non-empty right here, it'll jump me to the non-empty, where non-empty was defined within the source code. Let's do another example, like where is whereas block 2 lines define, and it's up here too. Another feature of jump to support is, ignore this little idiom. This is a workaround, which I won't go into during this talk, but you can jump to relative imports. So if a file imports another file and I click here, it'll take me to that file right there, core.dhall. And that, of course, like refers to all these other files as well. So it makes it easy to navigate between imports in that way. So also, sorry, there's one more example, which is Kubernetes. So we have auto-generated Dhall bindings to Kubernetes for several versions of their open API specification. We can actually see what's the default version that we support. So if I click here on package.dhall, it says by default that re-exports version 1.17 of the Kubernetes API. If I click on that, that in turn is a record which re-exports several sub-records, so schemas, types, and a large union. If I click on schemas, that'll take me to all of the supported Kubernetes resources, basically. So I can click on one of these, and then that has like a type, and then I can see what is the type of that resource. So this is a quick and easy documentation for like seeing like what are all the possible things that I can set, at least for Kubernetes. This document, there is not yet a Dhall analog of something like Hackage. So there's not a central repository for hosting packages and their documentation yet. So that's actually something I'm working on right now. There may be some, and so I hope to complete that soon, but I can't offer any guarantees yet. So the Dhall also, so the most widely used Dhall package is the Prelude. This is kind of like Dhall's standard library. It provides widely used general purpose utilities analogous to Haskell's Prelude. That's where the name comes from. It also provides support for commonly used formats like JSON and XML. So actually, one thing I didn't get into was that there are command line tools for converting Dhall to JSON or YAML or XML and so on. There actually also are utilities for doing that in pure Dhall without a command line utility. So you can actually render JSON using just Dhall code. And there also are utilities for types related to the core language. So like maps have some special language support, locations have some special language support, and so on. So right now, if you're wanting to discover packages other than the Prelude, again, there's not a central repository or discovery mechanism. The closest thing we have at the moment is a GitHub repository called Awesome Dhall, which hosts some more widely used Dhall packages within the ecosystem. So you may find that interesting. So let's also talk a little bit more about emergent properties. So we have support for packages and we have support for diffs. So we can use that to compute a semantic changelog. So for example, I can take a diff between version 18 of the Prelude and version 19 of the Prelude. And I can see, oh, well, we added a new operator subpackage for the Prelude. And then we also added a new concat-map utility for optional values. Or if I compare version 19 and version 20 of the Prelude, we can see, okay, a new render compact utility for JSON, a new replace utility for text. And we can see, this is a little bit verbose, but we can basically see, oh, the implementation of the render function for XML just changed. In this case, it was to actually make it to sanitize the input, basically. I won't go into the diff because we're working on improving diffs for things like this, but this gives you some idea that it can like highlight salient differences between when a package changes. This is addressing a question that came up earlier, which is what are some other ways which we use Dhall support for tests? And one other way we can do that is using Dhall to validate a configuration file. So this is an example taken from the Dhall discourse where someone was like, okay, I have some config type which contains an opacity, a min replicas field, and a max replicas field. And I want to validate that opacity is less than or equal to 100. And I want to validate that min replicas is less than or equal to max replicas. And so we can actually write a validation function which, given an input config, will assert that those two validations return true. And then if I run that validation on the configuration using Dhall support for tests, it will check that configuration file at type checking time, not at runtime. And so in this case, I've deliberately run it on a configuration which contains an invalid opacity. And so what will happen is that at type checking time, Dhall will say, oh, the assertion failed because the opacity is not valid. And it's using, again, the support for semantic diffs. So it'll only surface the tests that failed and will elide all the tests that pass because of that. Okay, so that's the end of the coverage about tooling. Do people have any questions before I move on to the language security guarantees?
There are no questions in the chat right now, but we can wait a couple seconds and see if any come in.
Another thing while we're waiting, Dhall has support for, Dhall has a to directory tree subcommand where you can actually like given a Dhall, so given like a nested record, you can actually convert that into a directory tree where like a record represents a directory and a text field represents file contents. So you can actually use Dhall to manage the file system, treating it like a pure data structure. That's one of the reasons why Dhall has support for JSON, rendering JSON and YAML in pure Dhall, because you can actually use that to like maintain a file system containing JSON or YAML files and implement it as like a single Dhall expression.
Are you familiar with Unison?
Yes. So one thing that Dhall and Unison have in common is the use of hashes extensively for like caching or tracking expressions.
Yeah.
I think they both independently evolved the same feature. It was just convergent evolution.
Yeah, we have to get you guys together.
Mm-hmm.
Torsten has another question. Go ahead, Torsten.
Yeah. Sure. I was wondering, like, if you could comment on this hashing property a bit. I mean, if you just ignore hash collisions, can we say in general that like if the hash of two programs is different, then they also must do different things, like are semantically different?
No, so the converse is not true. And
Right.
there's a statement, I think it's called Rice's theorem, which says that like, at least for something like system F or anything as powerful as system F, you cannot guarantee, you cannot reliably determine, checking if two functions are equivalent is not decidable. So like it's in general, you cannot prove that two functions, in this case, like if two hashes are not the same, does not necessarily guarantee that the two functions behave differently. And it's not, I mean, it's also not just Rice's theorem, like there also are some limits to how Dhall can reason about expressions, right? So like all those things I showed you before, like reasoning about Boolean arithmetic, those are built into the standard. So implementations have to implement them and there's a standard way of doing it. But there's a limitation to how much reasoning we can build in because it adds complexity to each implementation. But yeah, the long answer is no. Just because two expressions have a different hash, it does not mean that they behave differently.
Thank you. Very good.
I don't see any other questions right now.
Okay.
So maybe we can move
Let's
on.
then. Yeah.
Okay.
So now I want to spend some time talking about language security. So this is a very long answer to how we make sure that everything that Dhall does is secure, because that was kind of the original motivation for Dhall in the first place is, we want programming features, but we don't want things to get out of control. We want it to be like, we want it to feel as safe and inert as JSON, because that's kind of what we're trying to displace here. So Dhall was always trying to strike the right balance between programming language features and safety. There's a longer document which goes into more detail about what I'm talking about here. It's called Safety Guarantees. But to summarize things, I would just reiterate what the website says, which is that the language aims to support safely importing and evaluating untrusted Dhall code, even code authored by malicious users. And we treat the inability to do so as a specification bug. So like one of the requirements for the design of the language is that it should be safe to run bad code and it's not going to break anything. And I'll go into more details about how we make that possible. So first off, the least important thing that we do is Dhall is not Turing complete. And so for people who are pedants, being Turing complete the absence of Turing completeness does not mean much per se. However, if you can prevent Turing completeness, that probably means that you got several other things correct. So for example, usually the one way that you prevent Turing completeness is that you have some sort of a type system or some other form of static analysis, which is a good thing in and of its own right, regardless of whether or not you use it to reject Turing complete programs, regardless of whether or not you forbid Turing completeness. It probably also means that you have some way of eliminating escape hatches or backdoors, which is, again, a good thing in its own right, regardless of whether or not you use it to forbid Turing completeness. It probably also means that it definitely means that you forbid general recursion, which in my opinion is also a good thing in its own right, but that's because I'm more of a programming language purist. And also like there actually are very specific benefits of avoiding Turing completeness, like if you're a theorem prover, but Dhall is not really used as a theorem prover, so they don't really apply here. So usually when people say, I don't want my configuration file to be Turing complete, what they actually mean is that they want to forbid arbitrary side effects. They want their configuration files to be easier to statically analyze or even just reason about by humans. And they don't want their configuration files to throw exceptions. And Dhall does all these things too, but you can have these things and still be Turing complete, right? These do not exclude the possibility of being Turing complete. It's just that some people use Turing completeness as an umbrella shorthand for these features, because as far as I know, there's not a better term to summarize this bag of very useful language security guarantees. So here are the real safeguards that Dhall provides that make it much safer. So the first one is purity. So this is probably the most important safeguard out of all of them. So the only permitted side effect in Dhall is importing other Dhall code. So that means, for example, Dhall cannot compromise the host machine in any way. It can't delete or modify local files or break things or take down services or, I don't know, or run pkill on some process. So the import system also protects against data exfiltration. So there's no way in Dhall to leak information to an outside system. So it cannot harvest or leak secrets or keys and passwords. We've given a lot of careful thought to what all the vectors are for getting the information out of a system, and we've locked them down to make that impossible. Because actually, so this in particular is very important because this has actually been a big issue for when people use programming languages for configuration file formats. So if I remember correctly, in npm pack or node packages, they can use TypeScript for their package format. And because TypeScript is a real programming language, it can do all sorts of dangerous things to your system. And this has actually happened and triggered lots of widespread issues. People found that these package configurations were uploading or harvesting their keys or secrets or causing all sorts of damage. So it's rare when it happens. When it is, it's devastating. So that's why it's really important to lock this sort of thing down. And that's why I don't think it's appropriate to use something like TypeScript as a configuration language, because it just permits too many things. You can also, so if you're still really paranoid and you don't trust me, you can completely disable HTTP imports. And in fact, you can actually completely disable all imports if you don't even trust the file system-based imports. So you have that option if you want to be extra secure. But also, other than that, the language is completely pure. So the only other effect a Dhall program can have is via whatever program the configuration file is configuring. The second biggest safeguard that the language provides is the static analysis features. So specifically, the Dhall type system has no escape hatch. So as far as I know, it's definitely not a mainstream programming language that provides the same safety guarantees that Dhall does. So even in Rust, there's an unsafe keyword you can use to turn off Rust's memory safe guarantees. In Dhall, there is nothing like an unsafe keyword. There is no way to be turn off the type system, I want to cheat or whatever. It's not possible. So the second thing is that Dhall, in addition to type annotations, we can also have term level annotations, which is essentially what these hashes or integrity checks are. They provide even stronger guarantees about the content of an expression because there's a one-to-one correspondence between an expression and its hash. Modulo hash collisions. There's a blog post where I go into more detail about this if you're more interested. The third benefit is that Dhall is strongly normalizing. So given any expression, we can always reduce it to a canonical normal form, which is free of indirection or free of obfuscation. So this means that let's say for whatever reason, you ask your coworkers to go loose on your Dhall configuration files and they make a mess of things. Maybe they organize things the wrong way, use bad style, or I don't know, or add too much indirection, make things really incomprehensible. All you have to do is just say, Dhall, evaluate everything, just give me the plain data as if this was just an inert JSON file, and then that's much easier for humans to understand. So because a lot of times when people think about the trade-off between programming features and configuration features, they think of it as a spectrum, where it's if we add more programming features, we make things harder to understand or more indirect or harder to read. So we make things more write only. So we prefer writing programs rather than reading programs. But if you always have the ability to reduce any expression, even functions, to a canonical normal form, then there's no trade-off. You can have your cake and eat it too. You can add as many programming language features as you want, and you can get rid of them at the end by just evaluating everything, leaving behind inert or plain functions or data, which have no more indirection in them. So I also want to address safety guarantees around URL import specifically, because this comes up a lot. People ask about this all the time. So remote imports of URLs have additional safeguards. So we already talked about how integrity checks on imports can protect against man-in-the-middle attacks. Additionally, if you integrity check an expression, then it's cached. So this protects against usage tracking. It will only be fetched once and then never again. In fact, we actually have sophisticated tooling, like, so for example, there's Nix packages support for Dhall, so in the Nix packages support for Dhall will actually completely disables the remote imports entirely. So it enforces that you actually only use Nix to obtain expressions. So then you never fetch anything remotely. At least you only fetch it using the build system, which is a safer way of doing it. There's also in Dhall, there's conceptually an analog of a cross-site scripting attack. I won't go into what that means, but the Dhall has a protection against that, which is called the referential sanity check. And also, like for HTTP, so like in web standards, there's a concept of a same origin policy, and Dhall has something which is analogous to the same origin policy, which helps protect against data exfiltration. And then also Dhall has protections against server-side request forging. So Dhall actually uses CORS, which is a web standard for protecting exactly this. So here this is mainly for people who want to consult the slides later. By the way, I want to mention that if you want to find these slides, they will be available in the meetup description for this talk. And I'll also try to ask to make sure that the link to these slides also gets added to the YouTube description, since I believe this talk is recorded and will be hosted on YouTube. So if you want to follow these slides afterwards, go ahead and look there. But basically, I've already built and run some code, which will basically run a Dhall server that would be safe to host on the open internet. I'm not actually hosting on the open internet because I was too lazy to actually set up a public IP. So I'm only running it locally on my machine. But conceptually, it would be safe to have this Dhall interpreter running on the open internet. And so this interpreter will accept any Dhall expression, and it will interpret it, and including import resolution, and return the result back. And so I'll open up a terminal where I will do exactly that. So the server's already running on my machine. It's listening on port 80. So I'll say, okay, so curl localhost. Sorry, let me make this a little bit bigger so it's easier for people to see. Okay, so curl localhost port 3000, and here will be the payload 2 + 2. Right, so and that went to the server. Server interpreted, came back as 4. All right.
Are we supposed to be able to see that?
Oh, no, so yeah, my mistake. I'm only sharing my browser. So let me reshare really quickly to show this.
Okay, just checking.
Yeah, so yeah.
And I will put the link to the slides along with the video description on YouTube.
Yeah. Okay, here we go. So I'm switching to just the terminal. Let me also just resize things a bit. Okay. So yeah, so if we make a curl request to the server running on my local machine, we pass it 2 + 2, it'll return 4. And that was done. That was server-side interpretation. Whereas on the website, we did client-side interpretation in the user's browser. This is now real server-side computation. The server will handle parse errors. It'll handle type errors, import resolution errors too. So actually, let's do a real import. So let's say let prelude equals https prelude.dhalling.org/package.dhall in prelude.bool.not_true. Sorry, 2 quotes. There we go. Sorry, I made a typo somewhere. Oh, sorry. That's accidentally 2 commands. There you go. So returns false. And you may be thinking to yourself, wait a second, Gabriel, the server is fetching the prelude on my behalf. Isn't that server-side request forging? And this is where the CORS feature comes in. So by default, if you interpret a Dhall file locally from the command line, then it will, sorry, let me step back. So if a remote import transitively imports another remote import from a different domain, then there'll be a CORS check. We'll make sure that the transitive domain opted in to being imported in this way. And CORS has a way of doing that. So the prelude happens to opt in to this. So it actually will, say, I permit anything to transitively import me. If let's say I wanted to try to import, say, I don't know, reddit.com. And you can import things as text, even if they're not like Dhall code, and see what happens right there. So I give it a second to make the request, and it says, okay, not CORS compliant. Dhall supports transitive imports, but if you have a remote import transitively importing another remote import, then we need to fix that. And so the reason this is safe is because the server itself is configured so that it treats itself as already being a remote import. So anything else you import that you ask it to import will be considered to be transitive of a remote import. If we were to try to import that locally, like from the command line, that would be fine, because then the root import is not local. So this is permitted, because it's not a server, it's just the local command line. It'll just return whatever's in reddit.com. Okay, so let's try to break the server in another way, right? So like you said, Gabriel, I can import local files and environment variables, right? So what if I try to harvest the server's private key of whatever account happens to be running, the server happens to be running under? And the server will say like, nope, it's referentially a pig import. So Dhall actually keeps track of the chain of imports. And so once you import a remote import anywhere within the chain, all downstream imports from that point on have to be remote imports. You can never have a remote import which transitively depends on a local import, where a file import like this is a local import. Another example of this is if I try to import the user environment variable. Again, I'm trying to harvest secrets in some way, right? It'll reject it for the exact same reasons. Environment variables are treated as local imports, which cannot be downstream of a remote import. So like there's all sorts of safeguards in here to make sure that it's total. So like the worst thing we can do here is just like burn up server resources, like run a really expensive computation. So let me just quickly retrieve the Ackermann function that I was mentioning before. Give me just a second. Okay, you won't be able, well, here, well, actually, you can't see my browser, but what I'll do is just to show you what the function looks like, I'll interpret just the function. So I'll say, okay, here, here server, here's, oh, sorry, that actually, I accidentally pasted the code. What I wanted to paste was the URL for the raw code. Okay, so here's so on GitHub as a gist, I've hosted the Dhall equivalent of the Ackermann function. And this is the raw text for that gist, right? So if I interpret it, the code, it'll show you how you implement the Ackermann function in Dhall. And the Ackermann function takes 2 arguments. So I'll first provide the first argument, which is 10. And then because Dhall can do abstract interpretation, the server will interpret as much as it can. And now if I provide the second argument, this should basically take forever. It'll never complete as far as we're concerned, right? And the server in this case, I configured it to have a timeout. So at some point, it'll just give up on its computation and return a timeout. So if you do host like a public-facing Dhall interpreter, which is done server side, you'll need to have some sort of resource restrictions, either memory restrictions or CPU restrictions, to make sure that somebody cannot hog up all the resources. Okay, so let me go back to sharing my browser really quickly. Okay, there we go. And if you want to try out this example yourself, again, the code for this is going to be on the slides. Okay, so I basically, let me just go to the conclusion first, and then we'll do questions. So Dhall is a programmable configuration language with a strong emphasis on language security. Dhall's tooling and documentation is pretty good for a language of its age and its size. And you can use the JSON and YAML support to introduce Dhall incrementally within your organization. If you'd like to learn more, the best place to do that is to visit dhall-lang.org, which links to everything else. And if you want to find these slides later, they're hosted on GitHub, so you can peruse them at your leisure. And with that, that concludes my talk, and I'll take any questions.
Thank you very much, Gabe. That was, I mean, as awesome as I remember Dhall being the last time I looked at it. I'm just curious, are you using Dhall at work yourself?
Yes, we are using Dhall in a limited capacity, so I wouldn't say that our usage of work at Dhall drives a lot of its roadmap. We just use it in a few places, but not very heavily.
It seems like a natural evolution in a way to bring some of these powerful functional programming concepts to configuration languages, since so much of software development is migrating to just configuring things and writing tons of YAML and gluing systems together. Ulrich has a question. Ulrich, go ahead.
Yeah, I was wondering if all the security guarantees you have, are there formal proofs for that?
No.
Would that be possible because of the structure of the language and so on? That it's actually easier to...
I think the first... Sorry for interrupting.
No, that's it.
Yeah. So I think the first step in answering that question is, what is Dhall's threat model? Because without a threat model, you can't actually say anything like, is this language secure or not? Unless you say, what is the threat model? And so the threat model for Dhall is that the local system, the local file system or machine is trusted, and everything outside of that is untrusted. So for example, that's why we have the referential sanity check. The referential sanity check says that like a trusted import can import any other import, and an untrusted import can only import other untrusted imports. Basically, well, sorry, it's the other way. Sorry, it's the other way around. Basically, like, local imports can only import other local imports, and local imports can import anything, and remote imports can only import other remote imports. That enforces the one-way, that enforces the unidirectionality of information flow, basically. That's why you can never have a remote import pull in information from a local system. There's no formal proof of that, although I mean, at least for that specific property, I imagine it'd be pretty trivial to approve. You just need to verify that the interpreter is actually implementing what the language standard said to do, which is that like you can never have an import, a remote import something that's local. But yeah, I would say in general, the model is that like you trust the current machine, so you're totally fine about running anything on the same machine. The moment you reach out to anything remote, that's when you start putting up a whole bunch of safeguards to enforce those boundaries. There are some other properties which would be like a little bit more complicated to prove. For example, in Dhall, so like one feature of Dhall is that if an import has a relative file path, that relative file path references will actually work if you host the import remotely. So like we actually saw an example of that with the Prelude, if I actually go to that really quickly. So if you go to Prelude, so like let's say like the package.dhall, right? So like this Dhall code, these transitive imports are not URLs, right? They're actually relative file paths. So this relative import will work both if this were a local file, and it also works if it's a remote file. So if it's a local file, it's an obvious, you know, relative file path import. If you import this as a remote expression, then this will be relative to the URL. So there's logic in the standard saying like how to resolve those relative imports for URL imports. So like making sure that that handled is correctly might, you know, complicate things. For example, so one of the invariants in the import, one of the requirements of the standard is that any code that works as a local package should work as a remote package too, with some caveats. The exception would be like environment variables would no longer work, and non-relative file path references would no longer work. But otherwise, it should essentially still work. So that's a long-winded way of saying no, there are no formal proofs yet of various safety guarantees.
All right, thanks.
Mm-hmm.
So Thales has a comment I just want to read. He says, thanks for Dhall. I use it to generate Kubernetes manifests at work. It's much better than what was done previously there. And it kind of makes me want to ask something about Kubernetes actually, because it seems like the perfect use case for Dhall. And you had mentioned the template before.
I can talk about that general area. If that
yeah, maybe if you could talk about Kubernetes in general, because I'm wondering just how much of this sort of like pain can you automate with Dhall?
Yeah, so I think there are like 3 to 4 groups of people currently trying to implement the Dhall analog of Helm, where Helm is kind of like a curated set of Kubernetes packages, or like sort of like you know, vetted Kubernetes setups that are easy to install, tweak, and deploy. And I can tell you, if you try to do this, there are going to be a few issues that you will run into that are high priorities for me to fix. And the first issue would be once you start writing higher level utilities for performance, higher level utilities for Kubernetes, you'll start running into performance issues, because due to the fact that like some of these normal forms get quite large. If you try to cache them, then the cache gets large, and then, you know, decoding speeds get encoding and decoding speeds take a hit, and so on. So that's the first issue you're going to run into. Second issue you're going to run into is Dhall needs better support for making deep nested updates that are basically it's like deep nested updates that go through things like records, like being able to update all fields of records inside of a list. So Dhall kind of needs something like a JQ for Dhall for making like the easy deep nested updates. And we already have like some nascent support for that, but there's still a lot missing, which we're still in the process of implementing. Those will probably be like the 2 biggest things you'll notice if you try to start really rolling out a lot of Kubernetes utilities.
Thank you. Ulrich actually had a follow-up question. I think I missed. Ulrich,
yeah, it was
go
just
ahead.
very quick. You're referring to a standard. I suppose that's available somehow. Can you briefly say what that is and how it is actually the language is specified?
Yes. So on GitHub, there's a repository which is stores a lot of shared infrastructure for the community, including the language standard. There's a standard subdirectory which contains, the entry point is the README, which links to everything else. But basically the standard is specified using natural deduction notation, which you can think of as like pseudocode for people familiar with programming language theory. And it also contains a test suite as well. So you can verify that if you implement this pseudocode correctly within your respective language, then you should pass the test suite. Also, one of the things I'm working on right now is actually mechanizing the standard, meaning like providing a simple reference implementation side by side with the standard. So for example, there's actually a literate Haskell file in the standard for like the syntax. I'm sorry, this is gotta go to here. So like this is the way the standard represents the grammar, and then like side by side with the grammar is like actual Haskell code saying that like this is the equivalent Haskell type for the standard, and then this actually can be checked, so we can actually machine check that like the standard is consistent and valid and matches the tests and so on. So this is the Haskell mechanization of the standard is still incomplete. It's a work in progress, but this is one thing we're trying to do to make it easier for people to port the standard to new language bindings, and also make it easier for them to keep up to date with changes in the standard, because they can just look at the diff to the code and then be like, okay, yeah, that's the change I make to my sub project. If we wanted to get really fancy, we could like actually use a GHC API to automatically turn the Haskell code into automatically updated language bindings in these respective languages, but that'll be in the far future.
So at a certain point, you decided not to be a benevolent dictator for life.
Mm-hmm.
And,
yes.
And when did that happen? Why did you make that decision? And yeah, I don't know, benefits, trade-offs. I'm kind of interested in this community aspect. You briefly touched on it, but didn't go into details.
Yeah, I mean, I think it comes down to, I mean, personally, I just don't like the idea of benevolent dictators for life in general. I think it's like a bad way to run an open source project. Like even not for Dhall, like even my open source projects that are not, they don't have like quite sophisticated community governance. I have a tendency to be pretty loose with delegating responsibility. So like it's something I actually learned from Edward Komet, who in turn learned it from Audrey Tang, I believe, which is like, there's a development style where you just basically give the commit bit to anybody who sneezes the wrong way, and you sort of like very radical trust to new contributors essentially. And so I just sort of adopted that policy of radical trust with the way I govern Dhall. So like if you write a new implementation, then you get the exact same rights as I do as just yet another implementer. The second reason I do it is also because it helps promote trust in the language, knowing that it's not subject to the fickle whims of one particular person, right? They know that there are lots of people vetting the decisions going on, and there's formal processes around how language evolves, and they know that if they want to propose a change, then it's spelled out. There's a document explaining all of these things in detail, so they know that it's not just some a vague in-group of people who get to make all the decisions. The entire decision-making process is very transparent, and that can help instill trust in new users that Dhall is a foundation that I can build upon for my, my organization.
How long has it been like that?
Years, at least. Like very shortly after I started Dhall. I think probably within a year of starting. I have to go back. I'm not sure. Definitely years. Probably, I think within a year of me starting Dhall is when people started asking me to write a language standard document and start coming up with guidelines around these things. And
people asked you?
Yeah, well, basically there are a lot of people who were interested in implementing Dhall in their respective languages, and they were like, I would like to implement Dhall, but could you just write a language standard to summarize it to make it easier for me to implement? Because they didn't want to depend on the Haskell implementation, and so I obliged and I wrote the language standard. And then I just put some process around it so that they could contribute their own changes to it.
Oh, so it kind of grew organically.
Yeah.
Well, that must be very gratifying. That's really amazing. Mm-hmm. On the subject of community, Andrew has a question. Andrew, go ahead.
Yeah, hi. I wanted to ask, it seems that like the mainstream usage of Dhall is around Kubernetes. I just wanted to know if there was some other surprising usage from the community, something that didn't really expect it to be possible to do with Dhall.
Yes, there are several. It's hard for me to remember them. Like there's some organization. The only one I can remember off the top of my head is because it's recent. Is there some organization using Dhall as like to specify its rules, kind of like a weak, not really a contract language, but like basically they have like their formal documents and like shares in whatever system, their governance system. That's all modified as like one giant Dhall configuration file. So more other usages besides Kubernetes within the same domain is Terraform. So Terraform is, I think, is the second most common usage of Dhall within the DevOps domain. So yeah, there are lots of like small boutique applications of Dhall. I think probably the most interesting one that is being explored right now is using Dhall as sort of like the JSON for code in distributed systems context. So like the Java implementation, if I remember correctly, that's one of the motivations for it, because Java tends to be used heavily in distributed systems, and distributed systems usually want code to move between systems safely because that makes things easier to administer. Also, like, you know, it can also make things more efficient too. And so Dhall is perfect for that because it's a safe code, and that, you know, you don't need to worry about like code injection attacks or things like that if you're using it correctly. So I think that is one big area that still remains to be explored, but it's not Dhall's main focus at the moment.
I see. Thank you. Nice.
Mm-hmm.
So given your interest in evangelizing, I'm just curious if, I mean, I don't know how much actual evangelizing of Dhall that you've had to do or convincing of people. I'm kind of curious if you have any war stories about attempting to persuade or convince people to adopt, and like the resistance that you've met, how you've dealt with it.
Yep. I think the two biggest sources of resistance would be, one, the lack of type inference, and two, syntax. Syntax is like, there's two things. One is that like actual syntactic concerns, and the second thing is like Dhall has a standard formatter, and sometimes people don't like the way it formats things. So we're always trying to refine and improve the standard formatter, and sometimes people will refer to their concerns about the formatter as syntax concerns, and then usually just changing the formatter resolves their concerns. Sometimes people also use the term syntax to refer to issues that are non-syntactic. Like they sometimes will call the lack of type inference like a syntactic concern, which actually it's like a type checking concern, but the concern is still there. Those would be like the two big issues. So like early on in language design, people had a lot of concerns about the import system, but as we continue to refine and improve the safety guarantees around it, it's basically dropped off the radar entirely. And I think most of the concerns right now are basically syntax and type inference. And right now, the main concern I'm prioritizing is type inference. So we have people who are investigating ways to improve Dhall's type inference to make it more ergonomic.
These seem like the kind of concerns that would come from people who have experience with functional programming languages and statically typed languages, but what about like the DevOps community, or people who just kind of live and breathe the YAML and are comfortable with it, and Dhall kind of seems extremely alien to them?
I would say like people like to stereotype the DevOps community. They're actually more sophisticated than people believe, or more than the stereotype. Like, you know, like for example, like they will raise very sophisticated concerns about things like, you know, Dhall's equivalence checking, or like the way it, you know, or its type system. So they actually care about like these higher level details as well. But I would say like so going back to the original question though, Dhall's type inference can affect people even those who are accommodated to languages with explicit types like Go or Java, because even in some cases it can be a little bit more verbose than they're used to. Like the classic example would be like the map utility, right? The map function in Dhall is more verbose than it even would be in, say, like Java, or Go doesn't have a map function anyway, so I guess maybe they wouldn't care that much. But well, I mean, it doesn't have a map function because they have for loops, but Dhall doesn't have for loops, so it needs something as ergonomic as for loops in Go, and it does not have something as ergonomic as for loops in Go. So then they will still complain about it.
Yeah, okay. I'm just always interested to hear how people handle these kinds of situations, because I mean, I find it hard to introduce these kinds of tools myself.
Yeah, like that's why you really need a killer use case. So like for me, the killer use case is really obvious. It's Kubernetes, right? Like the situation in Kubernetes ecosystem is a mess. And like most people who use Dhall be like, this is the only sane solution to the problem right now. So they're willing to put up with Dhall's weaknesses, like the lack of type inference and so on, just because like they can finally have confidence in their Kubernetes configuration that no other tool really gives them.
Yeah, I have found onboarding into Kubernetes to be very challenging. Torsten has another question. Go ahead, Torsten.
Hey, yeah, it's me again. So I was wondering, like, if you're familiar with any examples where people have been using Dhall for configuring their machine learning model training loops. So like, I'm familiar with like JSONnet in that space, which is a configuration language which extends JSON with variables, conditionals, arithmetic functions, and so on. But I think Dhall would actually make it better, but I have not seen anybody using it.
Yeah, I don't remember. I can't say confidently either way if it is or is not being used. Like I can say confidently, it's definitely not a mainstream thing to do within the machine learning space, and it's not a priority for me personally to improve the ergonomics of using it for machine learning, because that's not the use case I'm currently focusing on. But it might be possible to use it for machine learning, because again, it's kind of like it's a safe first-class code, which is kind of unique among and like, you know, it's actually real code. Like, it's not like, you know, JSON. Like, you know, JSON doesn't have like IDE support, at least not meaningful IDE support if you're using it as a pseudo programming language.
Cool. Are you familiar with JSONnet? Have you heard of it?
Oh, sorry, I didn't hear what you said earlier. Yeah, JSONnet. Yes, I am familiar with JSONnet. I would say the biggest difference between Dhall and JSONnet is not typed. Like that's but it is more ergonomic because it doesn't have to deal with like all these type inference issues. So like that I think is the main trade-off between the two. The second biggest trade-off between the two is Dhall has much better language security guarantees than JSONnet. So like Dhall's niche is really for people who really care about safety and security, whereas JSONnet's niche is for like people who care more about the ergonomics of, you know, expressing the various code or transformations.
Thank you.
I believe Torsten just volunteered to make Dhall for machine learning model training configurations happen. So thanks, Torsten. We look forward to hearing back from you.
Glad I could help.
I don't see any other questions at the moment, but
yeah,
actually,
I have a hard cutoff in 2 minutes anyway, so.
Perfect. Okay. I mean, lots of compliments though. I mean, if you want to look at the chat, everyone is pretty impressed and amazed, but I'm sure you're used to that. It's very interesting project. Really, once again, delighted to have you talk to us about it this evening. Thank you so much, Gabriel.
Yeah, thank you very much. It was my pleasure.
And once again, I'll put the link to the slides onto Meetup and to the YouTube video. And I guess there are probably no other links that you needed to share with us, but you can always tweet Gabriel if you want to find out more about Dhall, and I'm sure he's happy to have your contributions as well to the community.
Yeah. All right then. Thank you very much too.
Okay. Thank you. Thank you everyone for joining. Thanks everyone for the great questions. Bye-bye.